Okay, so we didn't get to finish number 10. I'm going to have to stick it in with number 11, which is going to be line 11, Wild SETI Star Resin Identification Code, EMSpectrum, Spacecraft Sensors. And it's also going to include, from number 10, we're going to talk about the EMSpectrum. Okay, so let's go back down here. You have to look at the video on line 9 to find out the information about it. This is all the stuff on there. So we just went over the possible uses for SETI and why they use this signal that they send up and what frequency they use. It comes to 4.4623367 gigahertz, and the reason they use that signal is to let aliens know that we are from Earth, because we're the only ones that use that type of signal. So if you want to find a planet, say like Kepler, you would have to look at the spectrum of the data that you're looking at, and this is how they determined that those planets are habitable. So I've got all the data here on the left about spectral lines. See, there's lots there. Okay, so then I pull out what's important for us to learn about. First of all, spectral lines are the result of interaction between a quantum system, usually atoms, but sometimes molecules or atomic nuclei, and a single photon. Depending on the type of gas, the photon source, and what reaches the detector of the instrument, either an emission line or absorption line will be produced. That's these little black lines. Okay. Dark lines in a broad spectrum are produced when a cold gas is between a broad spectrum photon source and the detector. So this little black line here, that's what causes it. Okay, and spectral lines are highly atomic specific and can be used to identify the chemical composition of any medium capable of letting light pass through it. Typically gas is used. Okay, so several elements were discovered by spectroscopic means, meaning such as helium, thallium, and cerium. Spectral lines also depend on the physical conditions of the gas, so they are widely used to determine the chemical composition of stars and other celestial bodies that cannot be analyzed by other means, as well as their physical conditions. And then we talk about Pythagorean. He was in the last video as well. He proposes to use for SETI a frequency which is equal to pi times 1420.4 megahertz. Okay, so that was his calculations there. Such frequency couldn't possibly be produced in a natural way as a harmonic and would clearly signify its artificial origin. Such signal would not be jammed by the HI, which is the hydrogen line itself, or any of its harmonics. So the hydrogen line cannot interfere with that signal, is what they're saying. So this is my little picture. When we look at a rainbow, we get to see visible light. Okay, that's a good example of visible light. So we'll go over my thoughts here. January 13, 2012, 10:24 p.m. Eastern Standard Time. My thoughts. After doing some more digging into the links and data that came up from this search, I have finally seen what spectrum looks like and how they use it to determine the chemical composition of a planet to find out if it's habitable or not. I've pulled out some quotes on the right here to show you what's important from this data. First, we learn the importance of spectral lines found in the stars and planets. Then we find out that gases produce spectral types of lines which determine what the temperature of that planet or star is. We learn there are cold and warm gases out in the universe in this spectrum. When an object passes through the light, we can evaluate its spectrum. You find elements in this spectrum. Learning about the chemical composition of the stars and planets from the spectral lines gives us more clues as to whether it's habitable or inhabitable. Like in the Kepler planetary star region found by the Kepler satellite in late 2011, early 2012, thousands of habitable planets in the twin of Earth are discovered. I just found out that SETI uses this frequency when it sends its signals out to the stars and planets in search of alien life forms. So 1420.4 megahertz, pi times 1420.405, 75177 megahertz equals 4.46233 627 gigahertz. So that's the frequency that you guys want to tune into if you're looking for alien signals, and I believe SETI has a thing where everybody can participate with that. Okay, so let's click over to number 11. It's the line 11 Wells SETI star resin identification code EMSpectrum spacecraft sensors. So this is part 60, and it's the equation is 1 divided by 13 divided by 111 equals 0.0007. Okay, so the GRAPHSPACE constructor came up. It's Diff IRONCAMEL net graphic space 00007 IRONCAMEL net GRAPHSPACE. And the changes, it says revision history for net GRAPHSPACE, added support for no size auto, and of course I have no clue what it means. Okay, also comes up associated draft reports of knowledge management, and then a NASA thesaurus for aeronautics and aerospace related topics, the contents, disjointness or containment of a GRAPHSPACE, the same subset of triples, constructor, whatever, blah blah blah. All these links will be posted on my blog, okay, so you can look at them. And running mate for the IRONCAMEL, it talks about active Pearl, C-SPAN. Again, net GRAPHSPACE comes up again, parent directory. And then, so I look up the CST series high frequency SMT current sensing transformers. Senses current to greater than 10 amps for use between 50 kHz and 1 MHz. I still have no idea what these things are for. 2 samples of each value are Coilcraft Designer's Kit C389. And then the CST1 100 SMT current sensors. Of course, I look it up, and here's the data that comes up for it. And this is all the parts and information that came up, all from this frequency. Computer science, or computing science, is the study of theoretical foundations of information and computation. It also includes practical techniques for their implementation and application in computer systems. Computer scientists invent algorithmic processes that create, describe, and transform information and formulate suitable abstractions to design and model complex systems. Computer sciences has many subfields, some such as computational complexity theory, study the fundamental properties of computational problems, while others are computer graphics, emphasize the computation of specific results. Still others focus on the challenges in the implementing computations. For example, programming language theory studies approach to describe computations, while computer programming applies specific programming languages to solve specific computational problems, and human-computer interaction focuses on the challenges in making computers and computations useful, usable, and universally accessible to humans. Okay, so I've done that side, and let's go over to the right side here. See the WOW diagram, we're going to be looking at that. It says scientific notation or power of 10. Proper scientific notation is 1 digit not equal to 0. Followed by a decimal point, followed by any other significant digits, then multiplied times the appropriate power of 10. Scientific notation is very helpful when doing math in astronomy because we are often dealing with a combination of very large numbers and very small numbers. And there's the examples. Okay. And there's some more mathematical stuff here. Polyweb.com. Okay, a transformer is a device that transfers electrical energy from one circuit to another through inductively coupled conductors. The transformer's coils. So, Wiki Transformer, that's what they look like. This is from Coilcraft. These are brand new. They just created these in 2011. And this actually was released December 27th, 2010. So it's not even almost just a year ago, right? When they created these things. This is a patent for them. They're not actually, I don't know if they're being used yet or not, but that's the patent for a brand new, it's brand new technology. So surface mount current sensor CST1 Series, and you look up coilcraft.com, you can find it there. Okay, there's the WOW signal where I'm taking the equation of 1 divided by 13 divided by 111 right there. Okay, my thoughts. January 13th, 2012, 10:41 p.m. Eastern Standard Time. Just for the record, today is January 15th, and it's 10 a.m. So I'm 2 days behind. Okay, my thoughts. So this must be the types of components needed to build a faster UFO spaceship, because that was the question I asked in the first place. I don't know much about the mechanics here, but if you notice, this is the kind of stuff you find in them. New inventions keep coming up during my searches. These were made in 2011. Surface Mount Current Sensor CST1 Series. The word node size auto is under the difference IRONCAMEL net GRAPHSPACE 0.0007. So I do a Google on node and get binary tree. Interesting, the WOW signal is coded in binary numbers. So let's look up what binary tree is. From Wikipedia, that's what it looks like. And guess what? The first thing I think of when I see that, I think crop circles. Okay? Yeah, I'm recording. Just give me a minute, okay? A simple binary tree of size 9 and height 3 with a root node whose value is 2. The above tree is unbalanced and not sorted. In computer science, a binary tree is a tree data structure in which each node has at most 2 child nodes, usually distinguished as left and right. So this would be the child nodes, left and right, right? And nodes with children are parent nodes. So this would be the parent up here. And child nodes may contain references to their parents. Outside the tree, there is often a reference to the root node, the ancestor of all nodes. It is if it exists. Any node in the data structure can be reached by starting at root node and repeatedly following references to either the left or right child. Binary trees are used to implement binary search trees and binary heaps. I've never heard of these. So this is what I thought of. See, I looked at this thing, and then I started looking at crop circles this week for the first time in my life. I haven't really bothered to look at them. They're very pretty, but they all have messages in them. And I looked at this one. I'm thinking, that looks like a binary tree, doesn't it? Just a bit, you know. Here you've got your root node, and then you've got your parent, and then these are the childs. So according to the Encyclopedia Britannica, the tree of knowledge, this is what they've called this particular crop circle, is connecting to heaven and the underworld, and the tree of life, connecting all forms of creation, are both forms of the world tree or cosmic tree. So this message is actually stating that we are connected, the earth is connected to the universe, which is connected to those. I honestly think they're telling us that we're connected to them, that they are originally from earth, and they want us to know that we are all connected together. So this would be your earth, this would be the parent, this is where the beginning of creation, this is the parent, this is earth, how it branches off into the different planets. And we got 1, 2, 3, 4, 5, 6, 7, 8, 9. See that? Here's our solar system. This is Earth, or maybe this is the sun. I don't know. There's 9 planets here, though. See how Earth? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. So this could be Earth, right? And Earth, they're saying Earth is connected to all of the planets. And then there's the parent node over here. They are connected to the solar system. That's what I get from it. The tree of life. There's a new thought for you guys. Okay, so this is someone else's graph here. They said the image depicts the tree of life derived from the flower of life created by Sloth Monkey. He does a lot of nice graphs and stuff on Wikipedia. Okay, so it comes up as a Mesoamerican world tree is what it. So it's again, it goes back to the Maya. Here's the data about it. Among pre-Columbian Mesoamerican cultures, the concept of world trees is a prevalent motif in Mesoamerican. Okay, so I'm running out of time with this video, so I'm going to have to speed it up. Sorry. This is what it looks like, the actual tree. Its scientific classification is Ceiba, Penatria, leaves, and fruit. Oh, I'm never going to get through all this. My videos are colliding with each other, literally. Okay, so, Mesoamerican world tree, Waka Kan or Yak Igmixchi. Among the Maya, the central world tree was conceived or represented by the Ceiba tree and is known variously as a Wakachan or Yamechi, depending on the Maya language. The trunk of the tree could also be represented by an upright caiman whose skin evokes the tree's spunky trunk. So the central world tree has been interpreted as a representation of the band of the Milky Way. The Milky Way is the galaxy that contains the solar system. See, I just said that crop circle is our solar system. Messier 100 comes up. Look at the data there. Coma Berencies IO comes up with this. And I've run out of time again. Maya, Virgo, Coma, Berencies, Dwarf Galaxy, Year Bearer comes up. And I'll see if I can review this in the next video, okay?